So let's have a look. We know that standard deviation is equal to 3 on 2, which means the variance of x is equal to 3 on 2 squared, which is equal to 9 on 4. And I know that the variance is given by np1 minus p, which in this case is 9 times p times 1 minus p, and that's going to be equal to 9 on 4. So if I divide both sides by 9, I'm going to get p times 1 minus p is equal to 1 quarter. So p minus p squared equals 1 on 4. So multiply everything by 4 and group. That's going to give me 4p squared positive minus 4p plus 1 equal to 0. So I reckon if I do 2p and 2p, negative 1, looks about right. I'll get 2p minus 1 all squared is equal to 0, therefore p is equal to a half. So there's my probability. Find the probability that x is at least 1. Probability that x is at least 1 is equal to 1 minus the probability that x is equal to 0, which is 1 minus probability that x is equal to 0. Well, I've got 9 trials, 0 success. Probability of success is a half to the 0, and 9 failures, which is 1 minus a half to the power of 9. And in a tech-free, we'd leave it at that. All right. What's question 2? Question 2 is a probability distribution just for a discrete. Doesn't say anything about it being binomial. So what I do know is that all of these probabilities have to add to 1. Yeah. So that means 0.27, so that's 0.3, 0.4, 0.59, 0.63, 0.93. So 0.93 plus a is equal to 1, a is equal to 0.07. Probability that x is less than 3. So that's the probability that x is equal to 0, probability x is equal to 1, probability x is equal to 2. Now for 1 mark, we really just need the answers. So what we're saying is it's going to be that one, that one, that one, which is 19, 22, 32.59. The mean of x is the sum of x times p of x, so it's equal to 0 times 0.27 plus 1 times 0.13, 2 times 0.19, 3 times 0.34, 4 times 0.07, which is equal to 0.13 plus 0.38. 334s, 312 is 1.02 plus 0.28. Yeah, can't remember what that one is. I reckon that's an 8. So we get 13 plus 38 is 0.51, 1.02 is 1.53, plus 0.28 is 1.81. If I had time, I'd go back and check some of my arithmetic there. It's possible, but hopefully you've got the gist. The median is where the 0.5 mark is. And 0.27 plus 0.13 is 0.4 plus 0.19 is 0.59. So at 2, that's when we pass the halfway. So the median is at x equal to 2. All right. Question 3. Again, we've just got a discrete variable here. discrete variable, and given e of x is 3, but y is 0.2 and b is 0.1. Okay, so first things first, we know that they all have to add up to 1. So 0.1, 0.4, 0.2 adds up to 0.8. So a plus b is equal to 0.2. And e of x has got to mean x times p of x. So that means e of x is equal to 0 times 0.1 plus 1 times a plus 2 times 0.4 plus 5 times b, 10 times 0.2, and that has to equal 3.5. So I get a plus 5b plus 0.8 plus 2, so 2.8 on this side, subtract it, so that must be 0.7. So a plus b has to, a plus 5b, a plus 5b is 0.7. So if we eliminate, a minus a is 0, 5b minus b is 4b, 7 minus 2 is 0.5. That is not working out, is it? So if I check my addition here, 0.1, 0.4, 0.2 is 0.7, that should be 0.3, which makes that 0.4, so b is equal to 0.1, and if b is equal to 0.1, a is equal to 0.2. Okay, so notice substituting a equal to 0.2 and b equal to 0.1 into the question doesn't work, all right? What is the median? So where do we reach 0.5? So let's add a. A is equal to 0.2, b is equal to 0.1, and we first reach 0.5 here. So the median is 2. 2 people are playing the game are selected at random. What is the probability that they win the same amount? So they win the same amount. So what is the probability that we get so they're the winning. So we'll have to assume that a 0 means you win nothing. So it's got to be a 1-1 or a 2-2 or 5-5 or 10-10. So the 1-1 is 0.2 squared plus a 2-2, which is 0.4 squared. 5-5 is 0.1 squared. A 10-10 is 0.2 squared. So 0.2 by 0.2 is 4 with 2 dots. 0.04, 0.16, 0.01, 0.04. We add them together. We get 0.20 plus 0.05 is 0.25. Okay. Okay, so let's set up a little tree diagram, I reckon. It's normally the best thing when we've sort of got two options there. Harry plays well given he slept well the previous night is 0.6. So playing well, play bad, play well, play bad, and it depends on whether you sleep well or sleep bad. Probability he plays well given that he slept well the previous night is 0.6. So if this is slept well, 0.6 that he plays well. If he didn't sleep well, it's 0.5, 0.5. Okay, probability that Harry sleeps well on Friday night is 0.3. So normally we can only fill that one out there at the very end. What is it on a certain Saturday Harry plays well? Okay, so to play well, let's undo that bit of it. Probability of play well, which is just P, is equal to sleep well and play well, or sleep bad and play well. Sleep well and play well is 0.3 by 0.6, or, so plus, sleep bad and play well, so 0.18 plus 0.35, which equals 0.53. Okay. Go back and look at our tree diagram and play back to the previous one. B, what is the probability that Harry has slept well on a particular Friday night, given that Harry has not played well? So probability of sleep, so let's get rid of that. So it's probability of sleep well given not play well or play bad, which is the probability of sleep well and play bad over the probability of play bad. Okay, now sleep well and play bad is 0.3 by 0.4 over, well, the probability of play bad is 1 minus the probability of play well. So 1 minus, what was 5.3? So it's equal to 0.12 over 0.47, which is equal just to 12 on 47. Okay. Question 5. From two events A and B are such that A is equal to that and B is equal to that. A intersection B is equal to that. Right. Bit hard to tell. Let's call that A intersection dash B dash. Okay. So as soon as I see dashes, A dash, B dashed, and we know that the probability of A is 0.3, which means A dash is 0.7. Probability of B is 0.4, so B dash is 0.6, and A intersection B is 0.15, so that means I can fill in all the other ones. 0.15 plus 0.25 is 0.4, 0.15 plus 0.15 is 0.3, 0.15 plus 0.45 is 0.6, and check the one going across. 2.5 and 4.5 is 0.7, very good. So A dashed intersection B dashed is simply equal to 0.45. A given B, which is equal to the probability of A and B over the probability of B. So A and B we know is 0.15 over the probability of B is 0.4. So it's 15 on 40, which is 3/8. If A and B are mutually exclusive, it implies then that A intersection B is equal to 0, which implies then if A given B will be equal to 0 as well. All right. So let's keep moseying through. Two fair die are thrown simultaneously. One dice is red and the other die is black. Find the probability that the same number comes up on each dice. Okay, so if you like, we've got a 1, 2, 3, 4. Let's even make it better by going 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So clearly there's 36 different options. And the same number is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 out of 36, which is 1/6. Find the probability that the number that comes up on the red dice is less than the number that comes up on the black dice. So let's list all. The number that comes up on the red is less. So it's got to be less. So let's count. If the red is a 1, the black can be any of those. If the red is a 2, the black can be 3, 4, 5, or 6. If the red is a 3, it can be 4, 5, or 6. If the red is a 4,
black has to be 5 or 6. If the red is a 5, the black can only be 6. And if we throw a 6 one, it can't be any of them. 1, 2, 3, 4, 5, 9, 12, 14, 15. 15 out of 36. Okay, so really it's just list your sample space, list the outcomes, and then count the ones that sort of match our table. So I can get a 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, 5, 1, 5, 3, 5, 5. So there's 9 numbers. What's happened there? Part C, the 2 dice are thrown simultaneously 4 times. Find the probability that odd numbers on both die occur at least once. So first of all, so there's a number of trials. So what I need is the probability of 2 odd first. So let's go back 9 ways I can get 2 odd. 9 out of 36, which is equal to 1/4. So that's the probability of success, if you like, at least once. And we know that the probability of x being greater than or equal to 1 is 1 minus the probability that x is equal to 0, equal to 1 minus, so it's 4 trials, so x is distributed binomially, 4 trials, probability of success 1/4. So it's going to be 1 minus, so 4 trials, 0 successes. What's a success? 1/4 to the 0 for a success, 3/4 to the 4 for a failure. There's going to be 1 minus 1 times 1 times 3 on 4 cubed, which is what, to the 4 I should say. So 3 3s are 9, 9 9s are 81. 4 4s are 16. Another 4 16s are 64, and 4 64s are 256. So 1 minus 81 on 256 is equal to, so 19, 75, 175, isn't it? 175 on 256. Okay. So that's a fairly common one where you might get a probability, then it swings into a binomial. Probability distribution of random variables given on the table below. What is the median? Median is when we reach 0.5 for the first time. So there's 0.6 there. So the median is at x equal to 3. Find the probability that x is greater than 3. So that's x is greater than 3 and x is less than 6 over the probability that x is less than 6, which is equal to greater than or equal to 3 and less than 6 means it's got to be a 3, a 4, or a 5 over probability that x is less than 6. So a 3, 4, or a 5 is 0.4, 0.1, 0.2, which is 0.7. Less than 6 is 1 minus equal to 6, which is 0.9. So therefore it's 7/9. All right. X is a random variable with a normal. What's a normal distribution doing in here? So let's leave that, okay? Because whilst you're probably coming back and looking at it, so you have done normal. If we go doing it as we go, we haven't done normal distributions yet, so it shouldn't be in there. So let's leave all of those, okay? We haven't done normal. All right, fast food outlets, 60% of orders are placed at drive-through counter include chips. It can be assumed that an order placed by one drive-through customer is independent of any other. Okay, so out of the next 3 orders placed at drive-through, at least 2 will include chips. All right, so we have 3 orders, so N is 3, probability of success is 0.6, all right, and they're independent. What's the probability that at least 2? So the probability that x is greater than or equal to 2 is equal to probability that x is equal to 2 or x is equal to 3. Since x is distributed binomially with 3 trials and instead of 0.6, I'm going to put 3/5. Okay, so then we're going to say we have 3 trials, 2 successes, and we've got 3/5 to the 2 times 1/5, 2/5 to the 1, plus 3 successes, which is 3, 3, 3/5 to the 3, 2/5 to the 0, which is equal to 3C2 is 3 by 3 on 5 squared is 9 on 25 times 2 on 5 plus 333 is 1. 3 on 5 cubed is 3 to the 3, which is 27, on 5 to the 5, which is 125 times 1. So I'm going to get 3 2s are 6, 6 9s are 54. 54 on 125 plus 27 on 125, which is equal to 81 on 125. Okay. How many orders would need have been placed at the drive-through counter if the probability that at least one order included was equal to 0.84? So this becomes a calculator one, doesn't it? So we've got our calculator. For 3 marks, I can't just go to a calculator and put an answer. So let's just see how well we can do here without a CAS. It might fall out. So I need the probability that x is greater than or equal to 1 is equal to 0.84, all right, which means 1 minus the probability that x is equal to 0 is equal to 0.84. So the probability that x is equal to 0 has to equal 0.16. What is the probability that x is equal to 0? Well, we have 3 choose 0. Probability of success is 3/5 times 2/5 to the 3. Oh, we need n, sorry. So we don't know if we've got 3 trials. So let's just get rid of the 3. So instead I'll just put an n there to make it obvious. So that's still 0, and I'm going to have n failures. All right. So that implies that 2 on 5 to the n has to equal 0.16. So I'll put 16 on 100. Nah, not going to be very nice. And what's 16 on 100? 8 on 50, 4 on 25, isn't it? 4 on 25. Oh, it works out for us, doesn't it? Look at that. So that implies that 2/5 to the n has to equal 2 on 5 squared. If I simplify that, that implies that n is equal to 2. So clearly it is a tech-free. All right, but again, it's one of those ones where you have to know your binomial distribution, the law for it. All right. Last one. So they must be all tech-free. Discrete random variable x has probability distribution given by blah, blah, blah. Find the value of p. So we know that all of these have to add to 1. First 3 are 0.3 plus 0.7. So 1 minus 0.7 equals p. P equals 0.3. Probability of x is less than 1 given. So we know from a conditional x is less than or equal to 1 and x is less than 3 over probability that x is less than 3. What's common to the top two? Well, it's got to be less than or equal to 1 over the probability that x is less than 3. So less than or equal to 1 is 0.3, and strictly less than 3 is 0.7. So we get 3/7. Don't leave your answer as a decimal on a decimal. The expected value of x. So E of x is simply equal to the sum of x times P of x, which is equal to 0 times 0.2 plus 1 times 0.1 plus 2 times 0.4 plus 3 times the p-value, which was equal to 0.3. So it's equal to 0.1 plus 0.8 plus 0.9, which is equal to 1.8. All right. Last one. Two events A and B. A is equal to that, B is equal to that. Find A union B dashed. A union B dashed. All right. So we do know, if they're mutually exclusive. So again, as soon as I've got the dashes there, I'm doing my table. A dashed, B dashed. So probably not big enough. A is 1/3, so A dashed is 2/3. B is 1/2, so B dashed is also 1/2. Now, if mutually exclusive, so this is the floater, makes that 0. Now, don't forget, so A, therefore, oops, there's my dash there. A intersection B dash is equal to 1/3. Okay, so A union B dash from my addition law is equal to probability of A plus the probability of B dashed minus the probability of A intersection B dashed. Okay? So probability of A is 1/3, probability of B dashed is 1/2, A intersection B dashed is also 1/3. So therefore, if they're mutually exclusive, A union B dash is equal to, what's it equal to? 1/2. For independent events, probability of A intersection B is equal to the probability of A times the probability of B, which in this case is equal to 1/3 times 1/2, which is equal to 1/6. So if I just redraw my table very quickly, just so we've got them both there, A dashed, B dashed, except this time we're told that the intersection happens to be 1/6, and I know that probability of A is 1/3, 2/3 for A dashed, B we said was 1/2, so A union B dashed is again equal to, so probability of A union B dashed is equal to probability of A plus the probability of B dashed, which haven't changed, minus the probability of A intersection B dashed, which is A 1/3 plus 1/2 minus A intersection B dashed is going to be 1/6, isn't it? Because 1/3 is 2/6. 1/6, which is equal to, put them all over 6, I get a 1 minus 3 plus 2, so 2 plus 3 minus 1, which is 5 minus 1, which is 4, 4/6, which is 2/3. All right, done.